Good morning, everyone. Okay, let us start. Remember, we have been learning Chapter 4, Climate. So, in the previous classes, we have discussed about regional variation in the climatic conditions, factors affecting climate of any place, and today we shall discuss about factors affecting climate of India. Now I shall share my screen. So today uh, we shall discuss about factors affecting India's climate. Okay, last time we discussed about climatic controls, that is factors affecting climate of any place. And today we shall discuss about the factors affecting India's climate, okay, particularly for India. So the first important factor is latitude. Okay, what is latitude? You have learned. Now let us see how do latitudes affect the climate of India. Okay, so let us read the text here. The Tropic of Cancer passes through the middle of the country, from Ranokut in the west to Mizoram in the east. Almost half of the country lying south of the Tropic of Cancer belongs to tropical area, and all the remaining area north of the tropic lies in the subtropics, and therefore India's climate has a characteristics of tropical as well as subtropical climates. Now let us see this diagram. Do you remember the heat zones of the earth? Heat zones. The sea. This diagram represents shows heat zones, okay, of the earth. I think you might have learned in the lower classes also. And see here, so here this is equator, okay, this is equator, and this is the Tropic of Cancer, 23 half degree north, and this is Arctic Circle, 66 half degree north, and here we have North Pole, and likewise here we have the Tropic of Capricorn, 23 half degree south. This is Antarctic Circle, 66 half degree, and this is South Pole. And you have learned that the lane between the two tropics here, 23 half degree north to 23 half degree south, is known as torrid zone, okay. So the lane between the two tropics is known as torrid zone, and likewise the lane between the Tropic of Cancer here and the Arctic Circle is known as temperate zone, and within the Arctic Circle we call it frigid zone, and likewise in the southern hemisphere also. So the lane between the Tropic of Capricorn and the Antarctic Circle is known as temperate zone, and this is the frigid zone. And let us say India lies here, for example, Okay, let us say this is India. India lies here. Then means this Tropic of Cancer passes India in the middle of it. And since this Tropic of Cancer is passing through the middle of India, half of India, okay, this half of India lies in the temperate zone or subtropics, and this southern half lies in the tropical zone. So that is the point mentioned in the book, okay. And here we have say this is the map of India, and you are seeing this is the what. So this is what, this is Tropic of Cancer, okay. So this is Tropic of Cancer, and I think you're seeing that Tropic of Cancer is passing through, okay. Let me increase the size. So Tropic of Cancer passing through the middle of India, okay, and because of this northern half lies in the temperate or what, temperate or subtropic, okay, in the subtropical zone, and the southern half this southern half, okay, the southern part of India, so lies in the tropical zone, okay. So that is the point mentioned here, okay. See, India's climate has characteristics of tropical as well as subtropical climate, because the Tropic of Cancer passes through the middle of India. Okay, are you clear, boys and girls? Any question?
No, sir.
Okay, and next important factor is altitude. Okay, altitude. You know, altitude means height of a place from the sea level. We have learned. So now let us see how altitude affects the climate of India. So India has mountains in the north. So what is the name of the mountain here? What is the name of the mountain lying in the north of India? Yes.
Himalayan.
Yes, Himalayan mountain. So the height of the Himalayan mountain is more than 6,000 meters. And India has also vast coastal area where the maximum elevation is about 30 meters only. That means we have a great range of altitude ranging between 30 meters from the sea level to 6,000 meters from the sea level. And these Himalayan mountains prevent cold winds from the Central Asia from entering Indian subcontinent. And it is because of these mountains that this subcontinent experiences comparatively milder winters as compared to Central Asia. Okay, now let us see how the Himalayan mountains affect the climate of India. Let us say here this is the peninsular India, and here we have the Himalayan mountain, and this is the Tibetan plateau. Let us say this is Tibetan plateau, okay. And so this is the Himalayan mountain. This is the Himalayan mountain, and this is the peninsular. Actually here you know, Tibetan plateau and this land in the north, that is Siberian part, okay, is very cold in the winter. And see, since we have the Himalayan mountains here, the cold wind from Siberia, that is from Russia, okay. So here we have cold winds here. So cold winds from Siberia cannot cannot pass through Himalayan mountain, because Himalayan mountain is very high, more than 6,000 meters above the sea level. And we know that cold winds are heavy and cannot climb up a mountain. And that is why the cold wind from Siberia are protected by the Himalayan mountain from reaching India. And that is why India has milder winter. That means winter is not so cold like Siberia or Tibetan Plateau. And if there were no Himalayan mountains, then these cold winds will enter India, and India would have been very, very cold. So in this way, the Himalayan mountains protect cold winds from Siberia, okay? Protects cold winds from Siberia. And one more point we have discussed earlier is that, see here from the Indian Ocean, here we have Indian Ocean. From the Indian Ocean, rain-bearing wind is blowing towards India. It is forced to rise up the slope of the Himalayan mountain. Clouds are formed, and here we have rainfall. And such type of rainfall is known as what? Orographic rainfall. Okay, as you see here, last time also we discussed about it. We have sea here, and from the sea, rain-bearing wind is blowing towards land, forced to rise upwards, clouds are formed, and here we have rainfall. Okay, so in this way, the Himalayan mountains are causing rainfall to India. Okay, so in this way, altitude affects the climate of India. Are you clear? Any question?
Yes, sir.
Okay, so next important factor is pressure and the winds. Okay, pressure and the winds. So climate and associated weather conditions in India are governed by the following atmospheric conditions. So climate in India is affected by the following atmospheric conditions. Those are pressure and the surface winds, then upper air circulation, and the third one is western cyclonic disturbances and the tropical cyclones. Now let us see how these atmospheric conditions affect the climate of India. Okay, the first one, so India lies in the region of northeasterly winds. Do remember the planetary wind systems? So these winds originate from the subtropical high pressure belt of the northern hemisphere, and they blow southwards and get deflected to the right due to Coriolis Force, and move towards the equatorial low pressure area. Okay, and generally these winds carry little moisture, and as they originate and blow over the land, and therefore they bring no rainfall. Just see here. So this is the planetary wind system. Okay, major pressure belt. So this is major pressure belt, and the wind system. See here, along the equator we have low pressure belt known as equator low, and at around 30 to 35 degree north we have subtropical high pressure belt, and around 60 here we have subpolar low, and this is polar high, and likewise in the southern hemisphere also you will get the same. And so from the subtropical high, okay, see here, see in this area, here we have high pressure, okay, high pressure, and from the subpolar from the subtropical high pressure, the wind is blowing towards the equatorial low pressure, towards the south in the northern hemisphere. However, due to the Coriolis force, it is deflected, it is turned to the right. So what is Coriolis force? We shall discuss later. So for the time being, so the wind blowing from the subtropical high pressure towards the equatorial low is known as northeast trade winds. Okay, likewise in the southern hemisphere also we have southeast trade winds. And so here in this case, since the northeast trade wind is blowing from the continents, So it brings little moisture, and hence it gives less rainfall in India. Okay, just see here. Actually, let us say 30 is here. Okay, so subtropical high pressure cells are here. Okay, subtropical high pressure cells. Okay, so here we have the subtropical high pressure cells, and from this area planetary wind is blowing in this direction, and this is called northeast trades, okay, or northeast trade winds. And since this wind is blowing from the continents, it brings little rainfall. Okay, and so that is why it gives little rainfall towards India. But here in the southern hemisphere here, we have these oceans here. I think you are seeing here. Okay, you are seeing here we have oceans, and it gives rainfall. That will be discussed later. Okay, and about the Coriolis force, just see here. Because of the Coriolis force, wind is deflected. So what do you mean by Coriolis force? Let us see here. Coriolis force is an apparent force caused by the Earth's rotation. Okay, and the Coriolis force is responsible for deflecting winds towards the right in the northern hemisphere and towards the left in the southern hemisphere. This is also known as Farrell's law. So Coriolis force is an apparent force, okay, which is caused by the rotation of the Earth on its own axis. We know that our Earth is rotating on its own axis, and because of this, okay, any object, we know that, see, we have this Earth, and this is the axis, and our Earth is rotating from west towards the east, and because of this rotation of the Earth on its own axis, any moving object, okay, relative to the Earth's surface will be deflected to the right. For example, this object is moving to the south, it will be turned to the right. Likewise, any moving object to the north will be turned to the left due to the rotation of the Earth on its own axis, and this is what we call Coriolis force. So it affects not only the wind but also the ocean currents or rifle bullets or any object, okay, or any object, maybe cricket ball or maybe football. So any object which is moving relative to the Earth's surface will be deflected to the right, okay, in this way in the northern hemisphere, and to the left in the southern hemisphere, as you see here. Here this is equator, okay, and you are seeing here, see, in the north every object is deflecting to the right. So this is the supposed direction, and this is the resultant. Okay, so the object is turning to the right here. Here again it is also turning to the right, here again turning to the right. In the southern hemisphere, the wind or the ocean current or the rifle bullet is turning to the left. Here also it is moving due north, but it is turning to the left. Here also it is turning to the left, here to the left. So in this way, every object, okay, which is moving relative to the Earth's surface will be deflected to the right in the northern hemisphere and to the left in the southern hemisphere. This is what we call Cordless Force, or it is also known as Farrell's law. And remember, there is no deflection along the equator. Okay, every object will be moving straight along the equator. That means Coriolis value will be 0 at the equator, and the value of Coriolis force will be increased towards the pole. It is 100% at the poles. Okay. So because of this Coriolis force, winds are deflecting to the right or to the left. And that is why see these northeast trade winds are deflecting as mentioned here. Okay. Are you clear, boys and girls? Any question?
No, sir.
And let us continue. Here, let us read this section. The pressure and the wind conditions over India are unique. During winter, there is a high pressure area north of the Himalayas. Cold, dry winds blow from this region to the low pressure areas over the oceans to the south. In summer, a low pressure area develops over the interior Asia as well as over northwestern India. This causes a complete reversal of the direction of winds during the summer. Air moves from high pressure area over the southern Indian Ocean and in a southeasterly direction, crosses the equator and turns to the right towards the low pressure areas over the Indian subcontinent, and these are known as southwest monsoons. And these winds blow over the warm oceans and gather moisture and brings widespread rainfall over the mainland India. Just see here, as mentioned in the book. Okay, here in the northwestern India, a high pressure area is developed over Punjab, Haryana area. Another high pressure is developed over the Tibetan Plateau. And because of these high pressure cells, okay, high pressure regions, okay, high pressure systems, wind is blowing from these high pressure areas over the low pressure areas over the oceans. You know, in the winter season, ocean waters are warm, and that is why we find low pressure over the oceans, whereas land surface is very cold, and that is why high pressure cells are developed here. One over the Tibetan Plateau, another over the Punjab, Haryana area, Rajasthan area. Okay, and because of these, wind is blowing from the Indian subcontinent towards the Indian Ocean, and this wind is known as northeast monsoons. Whereas in the summer season, okay, in the summer season, the condition is reversed. See, in the summer season, a big low pressure is developed over the northwestern part of India because of intense heating of the land. Another low pressure will be developed over the Tibetan Plateau, and because of these, the winds from the southern hemisphere, these winds are known as what? Southeast tracks. Okay, the winds from the southern hemisphere, that is southeast tracks. And as I told you here, 30° south is here, and here we find high pressure cells, subtropical high pressure cells. So winds are blowing from the subtropical high pressure cells towards the equatorial low here. So here this is equator, and because of Coriolis force, this wind is supposed to move towards the north, okay, due north, but due to Coriolis force, it is deflected to the left like this, and so this wind will be attracted. This wind will be attracted here in this area, and when this wind crosses the equator, again it will be deflected to the right due to the Coriolis force. Okay, the wind is supposed to move due north, but it is turned to the right in this way. It is turned to the right in this way, and thus causing rainfall here in India. And these winds are known as southwest monsoon. Okay, as given here. The see here, in summer, a low pressure area develops over interior Asia, that is over Tibetan Plateau, as well as over northwestern India. And this causes a complete reversal of wind direction during the summer. And the air moves from high pressure area over the southern Indian Ocean in a southeasterly direction. In a southeasterly direction. So this is southeasterly direction. Okay, just you may compare with the this planetary wind system also. So this is the wind. Okay, so this is the wind. This is the southeast trade wind. Okay, so this southeast trade wind is blowing over the Indian Ocean, and it is after crossing the equator, it will turn to the right due to the Coriolis force, and this wind is known as southwest monsoon. Okay, and since this wind is blowing from the sea, it brings widespread rainfall over the Indian mainland. Okay, are you clear? Any question?
No, sir.
Then another factor, upper air circulation. Okay, so in this region is dominated by the westerly flow. An important component of this flow is the jet stream. So what do you mean by jet stream is given here. So jet stream, so these are a narrow belt of high altitude westerly winds. Actually, not only westerly, easterly winds also there, and in the troposphere. And the speed of the wind varies between 110 kilometers per hour in the summer to about 184 kilometers per hour in the winter. So what are jet streams? Jet streams, you know, see, this is the surface of the earth. Okay, the lowest layer of the atmosphere, I think you may be knowing, troposphere. Troposphere. Above the troposphere, what is there? Stratosphere. Okay, so just near between the stratosphere and the troposphere, we have a one very thin layer known as tropopause. Okay, tropopause. And so a very fast wind is moving here just nearby the tropopause, and this wind is known as jet stream. Okay, this wind is known as jet stream. So it is around 12 kilometers. It is blowing around 12 kilometers above the surface. So this high speed wind which is blowing in the upper troposphere is known as jet streams. Okay, and these jet streams are located approximately 27 to 30 degree north latitude, and therefore they are known as subtropical westerly jet streams over India. This jet stream blows south of the Himalayas. Just see here, these jet streams. Okay, the jet streams are blowing here. So this is the jet stream, and these jet streams, let us say this is the Himalayan mountain. Okay, so these jet streams are blowing south of the Himalayan mountain in the winter season, but when the summer season sets in, this jet stream will be shifted north of the Himalaya. So this is the position for summer, and this is the position for winter for the westerly jet stream. Okay, westerly jet stream. Remember, the westerly jet stream is blowing south of the Himalaya in the winter season. It is blowing north of the Himalaya in the summer season. Okay, and the western cyclonic disturbances, here the importance of westerly jet streams are given here. Why jet streams are very important, okay, in affecting the climate of India is given here. The western cyclonic disturbances experienced in the north and northwestern part of the country are brought in by this westerly flow. Okay, just see here. Let us see this world map. Here, this is the Mediterranean Sea. Okay, so this is Mediterranean Sea, And in winter, over the eastern part of the Mekong Sea, a weak cyclone is developed here in the eastern part of the Mekong Sea. And this weak cyclone is known as western disturbances or western cyclonic disturbances. And this weak cyclone is carried towards India by the westerly jet stream. Okay, westerly this jet stream. Okay, so these western disturbances are brought towards India by the westerly jet streams, and thus causing winter rainfall here in the northwestern part of India, heavy rainfall over the Himalayan mountains, and a light rainfall over the northeastern India. So this is the importance of the western cyclonic disturbances and the westerly jet stream affecting the climate of India. Okay, as given here. And in summer, the subtropical westerly jet streams move north of the Himalayas, as I told you earlier, with the apparent movement of the sun. And an easterly jet stream called the subtropical easterly jet stream blows over the peninsular India approximately over 14 degrees north during the summer months. Let us see this map. Just see here, as I told you, in the summer season, okay, the westerly jet stream blows north of the Himalayan mountains, that is over the Tibetan plateau. And during this time, okay, one more jet stream is blowing here. Just see this line. Just this is okay. One jet stream is blowing here over the southern part of the Indian subcontinent, and this is known as tropical easterly jet stream. This is what? Tropical easterly jet stream. Okay, we call it easterly because the wind is blowing from the east. The wind is blowing from the east, and that is why tropical easterly jet stream. So that is the point mentioned here. Okay, remember the westerly jet stream blows south of the Himalaya in the winter season, but in the summer season it is blowing north of the Himalayan mountain and over the Indian subcontinent, that is in the peninsular plateau. An easterly jet stream is blowing here, okay, in the summer season. Are you clear, boys and girls?
Yes, sir.
Remember, jet streams, these are very high speed wind. Okay, these are very high speed wind blowing over the near the tropopause, or blowing about 12 kilometers above the surface. The speed is so high that sometimes commercial planes cannot cross these streams. Only jet fighters can cross the jet stream, and hence the name is given jet stream. Okay, and regarding the western cyclonic disturbances, I have already explained. See here. So these are the cyclonic disturbances. Okay, these are weather phenomena of winter months brought in by the westerly flow from the Mekong region, and they usually influence the weather of the north and southwestern and northwestern region. Okay, so because of the western disturbances, also known as western cyclonic disturbances, we are receiving winter rainfall over the northwestern India. Okay, and heavy snowfall over the Himalayan mountain, and northeastern India is also receiving light winter rainfall, and this winter rainfall is very much beneficial to the Rabi crops. Okay, so we are growing wheat, then other Rabi crop like cabbage, then potato, peas. So all these crops are benefited by the this winter rainfall brought in by the westerly jet stream. So any other question, boys and girls?
No, sir.
Okay, then for today up to here. Thank you very much for joining my class. Thank you all.
Thank you, sir.
Thank you, sir.